For centuries, people have marveled at the sight of comets soaring overhead. Comets have been interpreted as divine omens, heavenly bodies flying through the sky and off into eternity. But in 1705, astronomer Edmund Halley revolutionized this idea. Using Isaac Newton's gravitational theories, Halley was able to prove that comets observed in 1531, 1607, and 1682 were actually the same one, and he predicted that the same comet would pass by again in 1758. 16 years after his death, Halley was proved correct, and the comet was named in his honor. Here we are looking at the solar system. Halley's Comet is now one of the hundreds of recorded periodic comets, or comets with orbital periods of less than 200 years. Halley's 76-year orbit extends from beyond Neptune to just outside Mercury's path. You may notice the highly elliptical shape, which is very different from the almost circular orbits of the planets. With an orbit so seemingly unique, where did this comet come from? Originally, astronomers believed Halley's Comet came from the Kuiper Belt. Similar to the asteroid belt between Mars and Jupiter, the Kuiper Belt is a ring of rocks and dust from the creation of our solar system. The Kuiper Belt is one of the largest regions in our solar system, and its inner edge is formed by Neptune's orbit at 30 astronomical units, or AU. The main region ends around 50 AU, but a second region, called the scattered disk, spans out nearly 100 AU. Many of the periodic comets in our solar system originated here in the Kuiper Belt. For example, Lexell's Comet and Churyumov-Gerasimenko both began as Kuiper Belt objects that were pulled inward by the gas giants. Notice how these comets orbit in the same counterclockwise direction as the planets. This is called a prograde orbit. Now looking at Halley's orbit, we can see some differences from these Kuiper Belt comets. First, it travels in the opposite direction. This is called a retrograde orbit. You can also see how the periodic comets' orbits are relatively in line with the plane of the solar system. Halley's Comet, on the other hand, is at a noticeable slant or incline from this plane. Halley's orbit more closely resembles these other comets. As you can see, they are sharply inclined off the plane of the solar system. Hale-Bopp and Lovejoy are also very elliptical like Halley's Comet. You may also notice the direction of the orbit. Like Halley's Comet, these comets also display a retrograde orbit. These peculiarities make it difficult for astronomers to believe these comets also came from the Kuiper Belt. Rather, many believe they originate from the Oort cloud. The Oort cloud is a theoretical cloud of objects surrounding the solar system, many times larger than the Kuiper Belt. The Oort cloud is thought to begin between 2,000 and 5,000 AU and extend thousands of AU outward. However, no object has been directly observed in the distant Oort cloud, leaving it a theoretical concept for the time being. In recent years, astronomers have shifted towards believing that Halley's Comet also began its life as one of these long-period comets, but was deflected or gravitationally pulled inward towards the Sun. These comets are formed from the same material that is left over from the creation of our solar system. Learning about these celestial wonders and how they form will help us understand how our own world came to be.